This
ఇంకోటి
conference
నిన్నటి
will now be recorded.
సో నిన్నటి
Sorry, I'm
రికార్డింగ్
not
ఏమైనా ఉందా
getting.
మీ దగ్గర? ఎస్టర్డేస్ రికార్డింగ్
ఉంటుందండి.
ఓకే, అది కూడా పంపించగలుగుతారు నాకు.
అన్ని పంపుతాను యాక్చువల్గా.
ఓకే,
నో ఇష్యూ. Yeah, then coming to okay. Can you please mute your mic, please? Yeah. So it's completed, right? So up to like what are the advantages of a Bitcoin? It's completed. So today we will discuss like what are the cryptographic algorithms we will use in the Bitcoin, and how these will be work, like what is the purpose of that exactly that algorithms, and what they will do. I will explain now. So see here in the public key cryptography, the main thing is, suppose if I did any transaction, so the first
Nani garu,
and foremost, yes,
I can't see your screen. So did you share your screen?
actually I shared the screen.
I can't
Not
see
getting.
it.
Okay.
I'm seeing the create meeting screen.
This conference will now be recorded.
Yeah, though the now in the in Bitcoin, the main thing is actually, so up to advantages is completed. So now we have to see that suppose if the transaction is initiated, so once the transaction is initiated, what will happen in the next level. See, once the transaction is happened, so we have to check that whether the transaction has initiated by the rightful person or not. Suppose I try to send 1 Bitcoin to you, right? If you take that example, so in that case what will happen, whether I'm sending 1 Bitcoin to you means I have to first it has to check that algorithm has to check that whether this person has the 1 Bitcoin or not. That Bitcoin, the main owner is this whoever's sending that particular person, whether he is the rightful owner or not. So that is the thing we have to check before sending it, right? Once the transaction is initiated. So for that purpose, actually we have some concepts that is called private key and public key and digital signature. So digital signature is nothing but once the transaction is initiated, the transaction will be bind with the public and private and some algorithms in between them, some encryption algorithms like encryption and decryption things we will do. And we will I will explain more about the digital signatures in Ethereum, like once we will start the Ethereum, in that I will explain. Here I will explain like what exactly it is. So the main purpose of these digital signatures is once the transaction is initiated, we have to know that whether this transaction was initiated by the rightful persons or not. So that is the main thing. And here the public key and private key. So what are these public key and private key? Once the wallet is created, so yesterday I told, right? So we will use some passphrase and we will create one password also, right? So in that case, once it is done, so in that case, so once the registration process is completed, so automatically the wallet will create the private key and public key. So what will happen, suppose if I want to send 1 Bitcoin to you, so in that case what will happen, so I want to send it to your address, right? So that address is nothing but that is public key. So whichever the address is visible to all the people, suppose if anyone wants to do a transaction with you, so in that case whatever the address you require, so that we call it as public key. And what a private key, private key is nothing but which is like our password. Generally in net banking or in other systems, what we will do, we will keep our password very secure, right? So same like that here also the private key is main important one. While doing the digital signature, it will be helpful. So these private keys, it's a very like it we have to keep it very secure. Okay, once the private key is revealed, so other persons also can spend our bitcoins, right? Because of by using this only we will do so. So that we have to keep this private key as very secure. Okay, so the main purpose of ECDSA algorithm is making the transactions like we have to do a signature, right? So for that purpose, that ECDSA algorithm will helpful, and it will take care of all these signing things. Okay, whoever sending, whether this person is rightful person or not, and everything it will take care of. Okay, understand, right? What is a public key and private key and signature, and you can know more about these words in the future. Like once we will enter into the Ethereum, in Ethereum I will explain how exactly the digital signature will happen, how the transaction will start, and in between how this will be signed, and it will send it to the other person, like a remote person. Okay, everything will be, we can see that time. Okay, so this is the ECDSA algorithm. In next one we have the hashing. Once the transaction is initiated, so later once the digital signature is created, so we will do like hashing. So it's hashing is nothing but it's a one-way hashing. So I told actually yesterday, and in the introduction class also I used many times, like proof of work algorithm. This is, we call it as proof of work algorithm. In Bitcoin, Hashcash is the proof of work algorithm. So the main purpose is like what will happen generally in the network. Suppose if it is open to everyone, some people will try to destroy it, like us sending multiple requests in within seconds, or by doing some other attacks. There is a possibility, right? In the network every time we will see that too many attacks will happen. So there is a possibility. So for that reason, this hash cache will take care of that, all these things. If we get the number of requests, so hundreds and thousands of requests also, it will validate that whether this is right or not, wrong. So it will validate, and it will give it to, it will add to the block. So this is the algorithm where proof of work is involved, and it will take care of these things. So in the Bitcoin, the proof of work algorithm we will use is the hash cache, and here we will use the hash function. So here you have to know one point, that is one-way hash function. So what is a one-way hash function is nothing but, suppose if you give any string, suppose my name is like Nani, if I give the any string, any type of string, so we once it is hashed, we have the too many hashing algorithms. In that, SHA-256 is the one of the algorithm, and we have the KEGAC-256 is the one more algorithm. So like that we have some hashing algorithm. These are the one-way hashing algorithms. Once it is hashed, we cannot revert back. Suppose my name is Naresh is hashed, and I got some fixed length of like hash value, but by using this hash value I cannot get back to this function, like whatever my name is Nani, yeah, I cannot get back. So that we call it as hash one-way hashing. So here in the Bitcoin, and we will use the SHA-256 is the one of the hashing algorithm, and in Ethereum we will use the KEGAP256 presently. I think so. I have to check it once. So okay, understand like what is like what ECDSA will do and what Hashcash will do. So these are the two algorithms where in the transactions, while doing the transactions, these two are the main key points, like key roles in the transaction. One is proof of work algorithm. So here I understand limit the email spam, because actually we kept some transaction fee also, right? Because of that also we will not get much email like spam uh, spam transactions, because if you want to do spam transactions, definitely you have to keep some transaction fee, definitely, right? So it's a loss to the like whoever doing that attack or that particular operation, he will lose some amount of Bitcoin, right? Definitely. So, and one more thing is denial of service. The denial of service is nothing but in the networks. Suppose if I want to trying to do any transaction, or if I want to do like getting some data from the network, what the people will do is they will make the network unavailability, so that we will not get the data back. So in these type of attacks also, it will take care of Hashcash will take care of these things. And in the one-way hash, why we use the one-way hash means, so suppose that transaction is happened, so this is finally encrypted, and that encrypted we will create finally like hash. Okay, so this hash, once the transaction is received, he will also decrypt, and he will check that whether this hash, whatever the end user has the hash, and what the sender has the hash. If the both hashes are matched, so that time we can confirm that the transaction is valid, and everything in between, nothing has been changed. So this is the main function of this Hashcash. Okay, Hashcash algorithm. And next one is transaction mechanism. What are the transaction mechanism in the Bitcoin? In the Bitcoin, we will use the UTXO model. So UTXO is nothing but unsent transaction output. So here, if you observe this thing, just you observe this, and I will explain you clearly. See here, one person has the some 100k some satoshis or whatever, so some Bitcoins he has. So in the input, suppose in the network, I was joined just now, I was joined, and I got some 100k Bitcoins in the mining I got. So all are in the form of input, right? So for the input I got 100k Bitcoins. Suppose not 100k, 10 Bitcoins I got. So if I want to spend that Bitcoins, so that 10 Bitcoins, among the 10 Bitcoins, I want to send 2 Bitcoins to the some other people. Okay, so that is output transaction. What will happen? These 10 Bitcoins, I will give it as a input. Okay, so but I want to send only 2 Bitcoins. So in that case, that 2 Bitcoins will be transferred to the remote person, and remaining whatever we have, the remaining 8 Bitcoins, that 8 Bitcoins will come to my account again with the new address. So I will show you like okay, see, suppose Alice is the person, so he wants to do some transaction with Bob. Okay, so Alice has them, he has uh, 3 Bitcoins already. Okay, but Alice has 10 Bitcoins. Okay, now this Alice wants to do one transaction with Bob. So what will happen in the input? in the input he will give, in input he will give the 10 bitcoins, 10 bitcoins, but among the 10 bitcoins he want to spend only 2 bitcoins. Okay, so what will happen once the transaction is done? So 8 bitcoins will be transferred to him, sorry, 2 bitcoins will be transferred to him, and total balance is what? 5 bitcoins, right? In the bob, 5 bitcoins. That remaining 10 bitcoins he given as input. So 2 bitcoins was spent, and those 2 bitcoins were sent to the bob, and remaining 8 bitcoins will be transferred to again this Alice account. Sorry. Okay, so in this we will have the again 8 bitcoins, 8 bitcoins. So these 8 bitcoins came like again we got, and with the new address, and we will get the new address. So because of these type of transaction mechanism, there is a possibility of not getting double spending and all these things. Okay, so it's a like in regular, if you take the banking system or yeah, whatever the transactions presently we are seeing, those are like I have the one account there, they will maintain my ledger, and there we have only number, right? Suppose if I have the 10,000 rupees, there we will see only 10,000 number. That 10,000 number, like if I want to send 1,000 to the some other person, so that transaction will check that whether this account holder has that much amount or not. It will check. Then automatically, if the value is greater than what I am sending, the transaction will happen, otherwise it will not happen, right? So but here in the Bitcoin case, it's a different case. So here, like whatever we are not spending, so that bitcoins will come back to our account again with the new address. Okay, understand? UTXO model. So you can see the diagram in that also. It will show that how a different transaction will happen, like that 100k Satoshi. So it is transferring in between the people with the different transactions. Okay, he spent to some one transaction as 40k, another transaction as 50k, and like that it will happen. Okay, and next one is Bitcoin transaction lifecycle. So in the Bitcoin transaction lifecycle, we can see that once the wallet is created, so what will happen once the transaction is initiated from the wallet? So the transaction is first broadcasted to all the people in the network and all the nodes in the network. So once it is broadcasted, what happens? It will validate by the miners. So they will check that whether this particular transaction is valid or not. Once it is valid, all the valid transactions will be stored in the particular block. Okay, once the block is completed, that means every block in the Bitcoin, there is a like 2 MB limit. If the block size is 2 MB, so automatically the mining like once the mining is completed, that hash will be tagged with the particular block, final hash. Okay, and next one is the once it is added, so now the block is like added to the chain. So whatever the changes has been done before adding it to the chain, so that's the final. So once it is added to the chain, so we cannot modify the transactions or whatever the features we have for the blockchain presently. So all the features will be applicable to the that particular block once it is added to the chain. Okay, so if you are trying to do any alterations for the particular block, So it will not happen because the miners are stamped that these particular block all the transactions are valid, and that will be added to the block. So there is a case, if suppose if any unvalid or if there is any malicious in the particular block, there is some other case actually that we will see in the next level, like if anything happens, so in that case what will happen and how it will get back, and again how it will form the valid blocks. So this is the one more concept, so that I will that we will see in the next levels. Okay, in Ethereum I will explain everything. So Bitcoin, why we are explaining, look, we will give the only overall idea because it's a first example. So that is the reason, for the blockchain it's a first example. So that is the reason, if you understand what exactly the Bitcoin, if you know the high level idea, then you will very much understand about the what Ethereum, and almost Ethereum and Bitcoin has the same type of features. There we will explain like somewhat like bigger. Here only high level idea I will give you. Okay, and next one is, so this is the transaction life cycle. Already I explained, so whatever I explained there, the same thing here. So like this is the like Bitcoin, once it is broadcasted, so it will go to the all the nodes, and that will be verified by the miners. So these are the miners, mining algorithms. So miners will validate all these transactions. Once these miners are validated these transactions, all the transactions will be added to the blocks. So these are the blocks. Okay, so in this block, like I told, right, in the Bitcoin there is a possibility like up to 2 MB it will take. Okay, up to 2 MB the transactions how many are there, so that many transactions will be added to the block, right? Once the block is added to the chain, so that's a final. So that will be added to the ledger, and now you can do the verification, like a transaction whether it is happened or not, you can check from your wallet. Okay, so this is the transaction life cycle, how it will happen in the Bitcoin. Okay, next, in the Bitcoin transaction, like we already somewhat we discussed yesterday, like what are exchanges. What the exchanges will do is actually they will keep some huge amount of like Bitcoins, ethers, and ripples. We have cryptocurrencies, too many cryptocurrencies are nearly, I don't know the exact figure, but mainly the familiar cryptocurrencies nearly 100 are there. So all these cryptocurrencies in exchanges they will keep all these cryptocurrencies. And if you want to do any like what we call uh, buying and selling, trading, if you wanted to do any trading, we will go for the exchanges, and in exchanges we have to buy the cryptocurrencies. Either it may be a Bitcoin or like whatever the cryptocurrency, you can buy the cryptocurrency. And if you want to do trading, and you can do it, or else you can keep the cryptocurrency with your with your account. So if you want to sell that cryptocurrency, so that time what we will do, we will sell that cryptocurrency in exchanges only. Then you will get back, like what you will get in the form of money you will get, because the exchanges will do that, they will take the cryptocurrency and they will give the money back. Okay, same like in generally in outside we cannot exchange these cryptocurrencies, right? But if you want money, like either it may be a dollars or whatever, so if you want the money, definitely you have to go to the exchanges, then only you can exchange the money with the cryptocurrency. In outside, so I cannot sell the Bitcoin, right? I cannot sell like directly. I cannot believe the one particular person, like I cannot send the Bitcoin some other person. Suppose if you ask me like you send me one Bitcoin, I will give the 5 lakhs. Blindly I cannot believe you, right? If I send the Bitcoin once, so maybe you will not send the money to me. So there is no like there is no authority on the top of this, so I cannot trust, right? So generally in these cryptocurrency exchange, like exchanging, buying or selling. So for this, generally we will use the exchanges. Okay, for exchanges we have too many, like Coinbase, Bitfinex is the one company. So too many are there exchanges. If you check, we will get some Bitcoin info, something like that. We have this some of the exchanges. Okay, Coinbase is the somewhat like familiar here. And the demo of the Bitcoin transaction. So this demo I will show you at the end. I think how in exchanges how the Bitcoins will be there and how we will do the transactions, that I will show you, and some demo of tracking the transactions. So that also I will see. Actually, if you open this website, so blockchain.info, I think this website is not working. Okay, I will check whether it is working or not. Recently I checked, I think so it's not working. Blockchain.info is the one website who will like where we can see the real-time transactions. Now on I will show you. Okay. Blockchain info, blockchain explorer. I think this site is not working properly. Okay, see here. Nothing else. Okay. Okay, these are the Bitcoin. See, last 12 seconds back, this block has been mined by this miner. Slush pool is the one of the miner. See, nowadays what's happening is the individual person. Suppose if I have the CPU, or if I have the GPU, so that resource is not enough to do the mining, because now nowadays the Bitcoin value was very high. It's nearly 5 lakhs, right? So the competition for mining is very high, because one block is mined, we will get nearly we will see that also 12.5 ethers, sorry, 12.5 bitcoins plus. So the competition for mining is very high. So that is the reason nowadays what's happening is that some people will combine, and combinedly they will pool and pool the resource, and they will do mining, and they are getting the, okay, see here. So these are the like timestamp. Height means like block height. So how many number of blocks are there till now? So next minor is the slash, and then number of transactions. How many transactions are there in particular block? So this is the difficulty. I will explain later what is exactly difficulty, and this is the Merkle root. Merkle root also I will explain. And this is the version bits and weight. That is the size. Okay, so see here, it is a block reward. So 12.5 bitcoins, and fee reward, fee for every transaction they will take some fee, right? So that is 0.2 bitcoin. So this total reward will go to this particular, whoever mined this particular block, he will get all the rewards. Okay, so this is the block explorer, and this is enough presently. Later we will see that. Okay, so for the Bitcoin transaction, I will show you later, because for that I have to open my exchange account and all this. One day I will already open, and I will show you. Okay, so this is the tracking of like how the like blocks will be created one by one, and that is happening. Like we cannot stop it, right? It's a default process, it's going on, right? And next one is Bitcoin mining. how the Bitcoin mining will happen. So that is the one question, right? So you know already high level, like Bitcoin mining is nothing but like we will just bundle the transactions into one block, and that block will be added to the chain. So once the block is added to the chain, that means the mining is done. So that we know high level. So in generally what will happen in the backend somewhat in detail. So I will tell you. So what's happening is in the network we have some 100 people are there. Just I will give small example. So we have the 100 people in the network. So what happens, suppose I did one transaction. So at the same time I think I got actually 100 transactions 100. So if we have the 1,000 people, so nearly 200 transactions I got. So what will happen once the transactions are came, that all the transactions will be stored into the transaction pool. Transaction pool is the place where unverified transactions will be stored. So once the transaction is initiated, those will be come to the this transaction pool. So next what will happen? So next the miner has to pick the transaction, right? So pick the transaction, he has to check that, and it has to add it to the block. So which type of transaction the miner will pick? See here, generally all the people, the mining people are doing mining because of money, right? Definitely because of he is getting some reward, so that is the reason he is doing mining, right? So in that case, what he will check? He will check that which transaction has the more transaction fee. Generally, he will check that. So based on that, he will pick the like transaction randomly. Also, he can pick, but if he wants to intentionally, if he want to pick, so he can pick like that also based on the transaction fee. If the transaction fee is more, so he will pick that transaction, and that transaction will be added to the block. So if it is completed, suppose the block size is completed, that 2 MB, nearly it will take 2 MB, and here two factors are there. 2 MB is there, and 10 minutes is the one, like in 10 minutes the block has to be validated. So that is the main goal. So once this is done, the proof of work algorithm, it will start working. So what it will do, it will, like I will give you small example how the proof, what exactly the proof of work. Proof of work is nothing but like if you have the random of keys, you have the 100 keys are there, one lock is there, so only one key is the valid key. So what the miner will do, so miners will like in generally in technically in generally is like we have to pick the valid key and we have to keep for the lock. Okay, that is the general scenario. In case of technically, so the proof of work algorithm, every second it will create like thousands of hashes. So if that hash is valid for this particular block, so that means it's finalized and the block is mined. So if it is valid, so until and unless it is valid, so algorithm itself, it will create like it will generate the number of hashes. Okay, the number of hashes will be increased. So why the mining is difficult in case like present days means, so this is also one of the reason why we require more resources. Also this is the one of the reasons. See, if we have the more resource, what will happen, the number of hashes generating for 1 second will be increased, right? So if this is increased, obviously the mining probability also increase. So mining of mining success rate also will increase. So that is the reason. So if you observe that blockchain.info, the maximum of the blocks was like mined by the mining pools only. In the mining pools, what they will do, they will collect the resources, and by using that resources, they will do the like mining. So if we have the more resources, there is a possibility of more like more chances to get the block mined. Okay, so this is the how once it is done. So once the block is validated, so that block will be added to the blockchain. So like local blockchain. So if you take the node, I'm doing mining, right? So once the mining is done, so that will be added to my local like node. So once it is done node, so that will be broadcasted to all the people, and automatically within the seconds the all the nodes will be synced with the my block, like whatever I have added. So that will be added to all the people, and all the people will check that whether the transactions are valid or not. So before going to add, so that will be checked by the miners, all the miners. If the 51% of the miners are accepted, that block will be valid. If suppose if not, that block will not be added to the main network. So this is the way how the Bitcoin mining will happen. So by using algorithms, we for this whatever I told now. So in the background, definitely that hash cache is the one of the algorithm it will take care it, right? So in this, the mining difficulty is the one of the main key role. So that we will explain in the Ethereum. So Ethereum and Bitcoin are both the same. So in that case, I will explain there and how the Bitcoin actually in Bitcoin we have the some of this set of the rules. So that rules are that block has to be takes these 10 to 12 minutes for one block mining. Otherwise there is a possibility of getting like more if the more blocks are validated within short time. So there is a problems in the algorithm, not problems, it will automatically adjust the like mining difficulty, all these things. Once we will get that topic, I will explain clearly and how this difficulty and these will be adjusted based on the like the number of miners are increasing, so what the problems are getting, so that I will explain. Okay, so this is the Bitcoin mining. And so if you see here how the mining, so the header of the most recent block, so I think in the first class I told, I think so. So what will happen, okay, I will show you now. Suppose in the blockchain is nothing but like chain of blocks, right? So so sorry, so this is the one block, okay, and so these are the number of blocks. So like this we are it's forming the blocks. So that case how this will be linked is the main thing is these are linked. So the linking will happen like suppose it has the hash, it will be finalized. This is the first block, this is the genesis block. For this genesis block, for every block, not only genesis block, for every block we have the two parameters mainly. Previous block hash is the main important and the present block hash. Okay, present block hash will be created based on the data contains, that means either it may be a transactions or whatever the total block. By considering the total block values, it will create the final hash, right? That is once that the mining is completed, we will get one hash, right? So that hash will be generated when by taking all the data in the block. Suppose if anything changed, anything very small, if anything very small, if you change the capital letter to small letter also, the block hash will be changed. So because of immutability, so one if it is genesis block, so here also I have to be two parameters, right? One is previous hash and next one is hash, right? So same thing will be for all the blocks. Okay, same thing, previous and present hash. Okay, so what will happen For the Genesis block, previous hash, it obviously it will take the zeros, all the zeros it will take. But for this hash, what it will do, because of Genesis block previous to the Genesis block, there is no blocks, right? So that is the reason automatically it will take the previous block has zeros. So once this is mined, we will get some hash, some suppose 1 2 3 I got. Okay, so what will happen next in the next block mining, before mining, so these hash will be added to here. So these, in this previous block, the value will be 1 2 3, right? So by using all these, so now this second block also hash sorry, mined. So that time I will get another hash, some suppose 5 4 5 6. Okay, so what will happen, so there is a link between the first and second. Again same thing, what will happen here also, here for the previous block hash, so I have to add it to this, and present block I will get some other value, right? So suppose if I am trying to change anything in the second block, what will happen, obviously this hash will be changed, right? Because this final hash is based on the total, like either it may be a data or the transaction, whatever. By taking all this, it is creating the one hash. But if anything changed in this particular block, what will happen, this hash will be changed. This hash will be changed means again that will be reflected here also, because here the previous hash is different, this has changed, right? So now whatever I have in this block, so this and this one is not matching, so this is also reflected like this. If anything changed in between the chain, if any block or if anything changed in the block, so that will be reflected on the next total chain, whatever we have. If we have the 100 nodes, after that, if we have the 100 nodes after the Genesis block, if you are trying to change the second block, so that remaining chain, that remaining total chain will be reflected. So that is the reason the immutability is the more like secure. We can trust that by by seeing this mechanism, right? So if anything changes, that will be reflected, and immediately the network itself, it will be known that something went wrong. Okay, so here in the mining, so it will take what it will take, header of the most recent block. Okay, propose a new block, and a nonce is the number, it will be increment every time. Okay, so what will happen, so that hash, new block, and this, by using these three, so they will form one hash number, and that will check that whether this is less than a target value or not. So once it is less than a target value, this target value has the different, like it has some different feature. So I will explain target value and mining difficulty, I will explain later. Okay, so it will check with this. If it is okay, that means the mining is completed, you got the you have solved the proof of work, and this will be mined. Otherwise what will happen, again the nonce will be increased. So this is the way how the hashes will generate, I told, right? So the number of hashes generating is more, so there is a possibility of getting the mining done very fastly, right? So here, so if you have the more resource, so definitely this process will be very fast, right? So this is the way how the proof of work, mining will be done, and how the blocks will be stored. Okay, and next things we will see tomorrow, what exactly the mining difficulty and all these things. So because of the next network adjustment, actually we will check all these things. Okay, any doubts till now? Actually I'm talking continuously.
హలో నాని గారు.
Hi Andy. Rajesh.
Hi,
Okay.
Andy.
Yes. Hi, Andy. Yes. Any doubts?
Yeah, Andy.
Hmm.
In public key, you will tell it is. Suppose I will send to Bitcoin to you. Anyone can
Okay.
see the transaction. In private key, some
Yes. Yes.
secured means some password is there.
Yes. Yes.
Hello.
Yes. 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 Tell me.
Some secured in private key, but there is no secured in public key. Suppose I will send to some Bitcoins to you. Some other wares can see the transaction.
Okay. Okay. Your question is others people can see the transaction or not, right?
Yeah.
Yeah, definitely, right. I shown you some blockchain info, right? Blockchain info is the one explorer. So there I can see
Okay.
that like whatever the there on the bottom of that we will get the transaction details. So from which address, from to which address the transaction is happened, how much amount has been transferred, like it is a 0.1 Bitcoin or whatever. So if you want, I
Okay.
will show you in detail. Actually, there in the block explorer, that is the block details. What I shown is the block details. On the bottom of that, we can see that. So what are the transactions happened in this particular block? So whatever the block, whatever the transactions stored in the particular block, we can see all that. All that on
Only
the bottom
basic
of that.
information can see.
Yeah, basic information means address, from which address to which address and how much. Okay. So
Okay.
these
In
are the
public
details
key,
we.
so, okay. In public
Yeah,
key, so password also there,
in the public
but
key
basic information
password.
can means in
Basic
private key
information.
some password.
Yeah,
Okay.
yeah. Private key is nothing but it's a password here. Like generally
Okay.
in general scenario, we can think that like password is nothing but private key, and public
Okay.
key is nothing but our email ID. Suppose if you know my email ID, what you can send
Okay.
the mail to me, right? Generally.
Okay.
Hello. So generally the
Yeah,
example
yeah. I
is
can
like,
understand.
yeah, like that. Any question?
One more thing. Uh,
Mm.
if I send the 10 bitcoins for input, but actually I
Mm.
have transferred 2 bitcoins, remaining 8 bitcoins, it will be stored on separate email address. Means separate address. You will tell separate address.
That's an internal address. Internal addresses are there for every Bitcoin. There is for every transaction. Sorry, not for the Bitcoin. For every transaction, there is
Okay.
the address. Okay, so that address will be changed. Okay, not for the not your public address. Public address is different. That's a internal address. Internally, for every transaction, there is a one address. Okay, so that address will
Okay,
change.
sir.
Okay, again, it will come as an input. Okay,
Okay.
input to your see. So general example is, suppose I have one account. So whatever I'm getting, like suppose I'm getting 5 Bitcoins every day. So every
Okay.
5 Bitcoins I will have one address. Okay, for every transaction,
Okay. Okay.
I will have one address. So like that here also, if I did any transaction, so suppose I have the 5 Bitcoins, so I want to send 1 Bitcoin. So that 5 Bitcoins as input, 1 Bitcoin will send it to the end user, and that 4 Bitcoins again it will come to my account with the new address. That's it.
New address. Okay.
Yeah, with new address. Yeah.
If you are telling in our yesterday class, address means email from one person to another person.
Yes. Address is different. Actually, see here, don't confuse. Public key is
Okay.
different, address is different. Okay.
Okay.
Okay, private key is
Okay.
different. Yeah.
Okay.
Any questions, Sai or Raviteja?
No, sir. No.
Okay. Okay, can I stop it then?
Yeah. Yeah, sure.
Okay. Okay, we will catch you tomorrow. Okay.